Happy New Year, everybody. Okay, let's get started. Let's solve Leetcode 2270, number of ways to split array. All right, let's make this bigger so it's legible. Okay. So we're given a zero index integer array nums of length n. Num contains a valid split at index I if the following are true. All right, let's read this carefully here. The sum of the first I plus 1 elements is greater than or equal to the sum of the last n minus I minus 1 elements, and there is at least one element to the right of I. Okay? Return the number of valid splits in nums. So this is our example here, and let's walk through it. So if we split nums into starting at index 0, that means by their definition, I'm just going to call it the left, or the first part, would contain the element, single element 10, and the right part, or the last part, I'm going to call it right, would contain these three elements, which sum to 3. And in this case, 10 is greater than or equal to 3, so we would consider this a valid split. Moving on, and the next potential split is to start at index 1, which is 4. In that case, the left elements, which are 10 and 4, add up to 14, are greater than or equal to negative 8 and 7, which is negative 1. So this is also considered a valid split. And lastly, considering index 2, all of these elements would be considered part of the left side, or the first part, and they sum up to 4. 4 is not greater than or equal to 7. Hence, this is not a valid split. And this is considered the last potential split, or valid split. We could not move our split up to here because they say there must be at least one element to the right. So this is the last index where there is one element to the right. Okay, so I think that's straightforward, and I think we can just get started. All right, so did I copy that down? Let's see. I think I did. Let's make this bigger for us all to enjoy. Okay, so my idea, or what I'll be presenting, is I think some people describe this as a prefix sum. For me, I would more consider it maybe a rolling sum, but let's go with it. So my idea is to we'll just say the total, and we'll just call this T, and this will equal the total of all elements. Total of all elements. So in this case, the total would be, what is it? 21 minus 8 is 13. Okay, 13. And what we'll do is we will loop through each element, and subtract I'll just call it the running total from grand total, which is T in this case, grand total. And perform our comparison. So, and then if this is true or not, we increment count. So let's run through with it. So this grand total is 13. So in the first index, when I equals 0, we have 10. Is 10 greater than or equal to, we'll just call this maybe, or let's just set this as running total. And I'm going to set this I'm going to call it just R, because I don't want to write running total. So what we'll do is, okay, I'll say, okay, running total plus equals the current element value. So in this case, it would be, so we'll set this equal to 0 initially. And then in this case, we'd add 10 to it, so R would be 10. R is 10. And then we ask ourselves, is R greater than or equal to the grand total, which is T, minus the running total, which is R. So this is 10, and the grand total is 13 minus the R, which is 10. So, and this is true. 10 is greater than or equal to, this is 3. So this is true. True, so we increment our count. And that's it. We just keep doing that. I'm going to do one more iteration just for a visual. Let's make this smaller a little bit. So we'll say, okay, now I equals 1. So now R is currently 10, right? R is currently 10. But our next value is 4, so that we say we always keep a running total. So we say R plus or equals now 4, so that gives us 14. So then we say is 14 bigger than or equal to 13? That's the grand total, minus 14. So let's check, is that right? So 14, yeah, that's right. So is 14 bigger than -1? Yes, it is. So we can just copy this here. And that's it. So we just keep doing this all the way through to the very end. Notice though, we'll have to stop a little bit early because according to their directions, we need at least one element to the right. So we'll just stop before that point. Okay, I think that's good enough for us to get started. So let us implement this. Let's make this smaller. Okay, so let's start it off. Let's make this, move it up a little bit. All right, here we go. So let's set up our count and our left running. We'll just call this this left will be the running total. So count is 0 and running total 0. Now let's find the sum of all the numbers. Okay, I'm not going to use num, so I'm just going to write n here, big N. So S equals the sum of n. Okay. Now let's perform our loop. So for I in range, length of n, -1, because we need one element to the right at the very least. Okay, so left, the running total. So we'll say left plus equals, sorry, n sub I. And then now we perform our comparison. We say if left is bigger than or equal to the grand total minus what we have so far. So if we have the grand total and we take away left, this would equal, essentially this is the right side, right? This is the right side here. So the left, and this is whatever's left over is the right. And then if this is true, we increment count. Okay, I think that's it. And now we just return our count. All right, let's check it out. Okay, looks good. Let me take off these comments. I don't think we need them anymore. Let's submit it. Okay, looks pretty good. All right. If you found this, I think this was a pretty straightforward. We can submit it again. I thought, again, I don't know if some would call this a prefix tree, for me it's more of a rolling total, and that's the way I would prefer to describe this. In any case, if you found this video helpful or instructive or beneficial, please consider liking or subscribing. Other than that, have a wonderful new year and take care of yourself. Have a good day. Take care.